All right, guys, so I'm just going to go through the practice test from beginning to end. I know we didn't have a ton of time in class, so this will cover anything that you didn't get to see. Okay, so starting with number one, we're going to be simplifying a whole bunch of monomial expressions. So the first one was this. We had a set of parentheses, and then negative 2, b to the negative second, c to the third, and the whole thing was raised to the third power. So when you've got that exponent on the outside, it distributes essentially to everything on the inside, like that third power, everything gets raised to the third power. The only reason that works is because there's no addition or subtraction. It does not work if there is addition or subtraction. So the negative 2 gets cubed, the b to the negative second gets cubed, and c cubed gets cubed. So when negative 2 gets cubed, that is like negative 2 times negative 2 times negative 2, and that is negative 8s. Next, when I have an exponent being raised to an exponent, I multiply those exponents together. So my new exponent would be negative 6. So I'm going to need to fix that. And then c to the third, same thing, those exponents will get multiplied. So for your final answer, any exponent that is negative has to get flipped. Don't confuse that with negative numbers. Negative numbers don't get flipped, just negative exponents get flipped. So my negative 8 stays, my c to the 9th stays, and then b to the negative 6th, I would flip it down to the bottom where it would become positive 6. So that would be your answer. For part B, we've got another monomial. We have 12 m to the 8th, y to the 6th that's in the numerator, and then the denominator is negative 9m y to the 4th. So everything that can reduce down will. The 12 over negative 9, they share a common copy of 3. So I can reduce down, kind of cancel out the 3's that they have in common. So divide this by 3, I'm left with 4. Divide this by 3, I'm left with negative 3. And then the m's, I have 8 copies in the numerator and 1 copy in the denominator, so I can cancel out this 1 common copy, and this would leave us with 7 copies in the numerator. And then with y, I have 4 copies in common, so all 4 of these will cancel out, and I'll lose 4 of these, leaving behind 2 copies of y. So let's rewrite what's left over here. So in the numerator, I have a 4, I have 7 copies of m left over, 2 copies of y, and in the denominator, all that was left over was a negative 3. Okay, so that would be your answer for that one. And then last in this section, we've got part C. So we've got a whole bunch of different variables here. And then just multiplying these two expressions together. So this kind of brings up one more thing that I haven't seen yet. So numbers multiply just like numbers always have. Like 4 times negative 5 is just negative 20. There's no special rules for that. And then with variables, what we do is we add their exponents. So when I have d to the second times just d, remember that's like d to the first, we're going to add their exponents together. So 2 plus 1 would give us an exponent of 3. Same thing with the t's, t to the 5th, t to the negative 3rd. When I add 5 and negative 3, I get 2. And then same thing with the v's, add these exponents, negative 4 and negative 1, and that would be the negative 5th power. Just like I did with part A, any negative exponents need to flip, not negative numbers though, just negative exponents. So the negative 20 stays, but the v to the 5th would now be in the denominator. So that would be your final answer. Forgot to box that one too. Okay, so those are some different exponent rules for something like number 1. Number 2, we have just addition and subtraction, basically just combining like terms for these two expressions. So let me just copy this down. And then this is addition. So be really, really careful when you see addition like that. Make sure that you know that all you're doing is you're combining like terms and you're not actually foiling or doing anything more complicated. So adding just means that we're adding like terms together. So we have 7y squared plus negative 4y squared, and that adds up to a 3y squared. So I'm just going to mark that I took care of those already. And then I have a 12xy and a 6xy. Positive 12, positive 6 would be 18xy, and again, just noting that I got those already. Negative 5 in front of the x squared plus negative 3 in front of the x squared. So just combining up those coefficients. And this would be your final answer. Once you've combined up all the like terms, then you're all done. Okay, number 3 actually is foiling. And I know there's a subtle difference between them, but the only difference is when you see something like number 3, notice that you do not have anything separating the parentheses. You just have just parentheses right next to parentheses, and there's no addition or subtraction or anything in the middle there. So that actually does mean that you're going to be FOILing out. So we start with this term right here, and you're going to multiply it to every single one of these terms. So first, 2n squared times n squared, and that would be 2n to the 4th. And then 2n squared times 5n, and that would be 10n to the 3rd. 2n squared times -1, that would be -2n squared. And then move to the next term, then move to this -3 and just repeat the process. So -3 times n squared would be -3n squared. -3 times 5n would be -15n. And -3 times -1 would be +3. So once you've done that, you've done a ton of FOILing, you're going to just take each like term, just like we did up in number 2. You're going to take any of the like terms that you have and combine them up together. So notice the only like terms that we actually do have are those middle terms. We have a -2n squared and a -3n squared. So I'm just going to rewrite it. This is the only 4th power. This is the only 3rd power, but then these two can combine up to a -5n squared. So we have every power covered here from the 4th power all the way on down to the constant. Okay, so that is number 3, and that's everything that we did in 5.1. We had a bunch of different topics in 5.1. Everything there is simplifying, either simplifying monomials or simplifying polynomials. So now we move on to number 4, 5, and 6 are all from 5.2. They're different types of division. So number 4, you've got division of a polynomial, which this term right here is a polynomial, and you're dividing that polynomial by a monomial. So I'm actually going to write it in a different form. So it said, in the note, it said divided by 2a squared. I'm going to write divided by 2a squared like that. So when you have a polynomial, meaning multiple terms, divided by a monomial, you can split up that denominator for every single piece. So you can take each individual piece and divide it by the monomial and just keep splitting it up. So each one of these pieces is getting divided by that monomial, and then we're just going to reduce it down as much as we possibly can for a final answer. So this right here, 4 divided by 2 is 2. A squared divided by a squared, those totally cancel out, and there's just an h squared left behind. Next, -8 divided by 2 is -4. A cubed over a squared leaves us with a single copy of a behind, and then still the h. And last one, 3 over 2 does not reduce, so I'm just going to leave it as 3 over 2. And then a to the 4th divided by a squared does reduce down to a squared. So that would be your final answer after you divide everything by 2a squared. 5 and 6, we had our 2 different methods of polynomial divided by polynomial. So number 5 was, we had 2t squared. So we're doing this by long division. So I'm going to write it out as long division. So you have t plus 5, that's our divisor. And then we're dividing into 2t squared plus 13t plus 15. Okay, so you set up long division like that. And we start by just focusing on this t right here. And we divide it kind of term by term. So first we're dividing just this term into just this term. That's all we have to focus on. So dividing t into 2t squared is basically the same as saying, now what do I have to multiply by t to get 2t squared? And that would be 2t. Because t times 2t would give me 2t squared. So then we set up subtraction, and we are very careful to set up parentheses, because otherwise we might mess up a sign, and then our whole problem would just domino. So then we take this 2t right here, and you multiply it back by this entire expression. Okay, so you're going to multiply 2t back by this whole expression, and that's what you subtract right here. So 2t times t is 2t squared. 2t times 5 is 10t. Okay, and we're going to be really careful with our subtraction. That's why we set up parentheses. So these cancel. And then we have 13t minus 10t. So that will leave us with a 3t. And then bring down the next term, plus 15. And then repeat the process. But now we're dividing t into 3t. So we're only focusing on these two terms. And think of division as like, what do I have to multiply by t to get 3t? And that would be 3, because 3 times t would be 3t. So I put a positive 3 right here. And set up your subtraction, set up your parentheses so we don't mess up any signs. And then we just do the same exact thing. Multiply this 3 by this expression right here, and that's what we subtract. So 3 times t is 3t. 3 times 5 is 15. and carefully subtract. So 3t minus 3t cancels. 15 minus 15 also cancels, so that would be 0 for a remainder, which means it divides evenly. There is no remainder. So our answer would be 2t plus 3. Little side note, remember, if there was a remainder, you would take whatever the remainder was and you would put it over the divisor, which is t plus 5. But in this example, our remainder was just 0, so you don't really have to write like 0 over t plus 5. This is the one case where we wouldn't write that. We just write this. But like I said, if you do have a remainder, you would have to write it like this. Okay, 6 is our other type of division, that's synthetic division. So this one, I'm going to write out the full problem first so you can see it. Okay, and then we are dividing it by x minus 3. Okay, so we take this thing, whatever we're dividing, and we're going to line up all the coefficients. So first coefficient is 2. Next coefficient on this term is a -1. This coefficient is a -19. And the constant is 15. If you're missing anything, you have to put a 0 in place. But we're not missing anything here because we go right from the third power to the second power to the first power to the constant. But if we were missing anything, we would have to put a 0 in its place. And then our divisor is x minus 3. Because our divisor is x minus 3, we're going to put a positive 3 in this little box. We always do the opposite. If it was x plus 3, we would have a -3 in this little box. Also, pay attention to the fact that this is technically just a 1 in front of the x. If there was anything else, maybe like a 2 or a 3 or something like that, you would have to divide everything by that number first. Okay, but we don't. It's just a 1, so we don't have to divide anything by 1. So the process works like this. I start with this first number, and this first number just gets brought right down to the last row, like that. Okay, so that one just gets a free pass down to the last row. Then it starts this process of multiplying and adding, and you just repeat until you get all the way to the end. So this 2 gets multiplied by this 3, and 2 times 3 is 6, so we put it right there. And then we add that column together. So we would have -1, or plus 6, I'm sorry, would be 5. And then multiply these. 3 times 5 would be 15. And again, we add this column together, and that would give us -4. And repeat the process again. -4 times 3 gives us -12, which we write right here. And then add these columns together, we get 3. So now that you're done, we figure out how to write it as a final answer. So these are now our new coefficients for our new answer. And this 2 is our first coefficient. Since this started off as an x to the 3rd power, this is going to start as x to the 2nd power. You're always dropping back ones. Like if this was x to the 6th power, this would start as x to the 5th power. So 2, like I said, is in front of x to the 2nd power. And then you just keep dropping down ones. The next one would be the 1st power, so plus 5x to the 1st power. Technically, you don't have to write that. That makes the next one the constant, so -4 is our constant. And this last guy right here is always, always, always the remainder. Okay, so remember how we talked up above on how to write the remainder. We write a positive 3 and then over whatever our divisor is, which in this case is x minus 3. Okay, so we write it out like that. Okay, and then on to 5.3, where we're looking at different polynomials, degrees, leading coefficients, things like that. So for number 7, I have 3 different examples, and we're asking, first of all, is it a polynomial with one variable? And then if it is, what's the degree, what's the leading coefficient? So first one, we've got this. So this one is a no, because we're asking whether it's a polynomial with one variable, and right here you can see we've got a mix of variables. So no, it can't be a polynomial with one variable because it has 2 variables. So that's easy enough. Move on to the next one. Okay, so this one all looks good so far. We only have one variable, not the same issue that we had last time, but in order to answer the questions about degree and leading coefficient, it has to be simplified and put into standard form, which for this one means foiling. So multiply the first 2 together, and we're going to have 6x to the 4th. Multiply the outside, and that would be a -27x squared. Inside would be 2x squared, and then the last term would be a -9. So to put it into its actual form by combining like terms, just combine up those middle terms right there. So for the degree the definition of the degree is the highest possible exponent. So this term's exponent is 4, this term's exponent is 2, and a constant technically has an exponent of 0. So the highest possible exponent would be this first one, which is 4. So the degree of the polynomial would be 4. And then the leading coefficient is always whatever coefficient is attached to that highest exponent. So that would be the 6. Okay, so the leading coefficient would be 6. Part C, we've got just one more of these here. First of all, asking, is it a polynomial in one variable? So it has one variable, which is good. However, when we have this variable in the denominator, that technically means that it's a negative exponent, and in order to be a polynomial, you can't have negative exponents. So no, and the reason is because we have negative exponents. We're not allowed to have negative exponents. We're not allowed to have square roots either. So if you ever see square roots, that also means that it's not a polynomial. Okay, number 8. Finding p of -2, and you're given that p of x is equal to this. So we want to find p of -2. So see how this, like our notation is the exact same here. We've got p, we have something in parentheses. So since we replaced this x with -2, that also means we want to replace these x's with -2. So that's how we do it. Okay, so whatever you see in parentheses, you just use that to replace the x. That's pretty much it. Then you just simplify it up as much as you can from there. So we have -7. If I square -2, I get 4. This multiplies out to a -10, and then plus 9. This would be -28 minus 10 plus 9. So that is a -29. So with something like that, if you're just plugging a number into a function, your final answer would just be a number when you're done. All right, number 9. Similar, but this one's going to be a little bit more complicated because I'm plugging in something more than just a number, which you should definitely know how to do. Okay, so I'm going to find -5 times r of 2a. Okay, so remember order of operations says we take care of exponents first, so we're going to worry about this part of it first. So remember, this notation means I use my function r, but every time I see an x, I'm going to replace it with a 2a, and then I'm going to come back for this -5 in just a minute. So let's focus on just this part of it first. So I go into this function right here. Every single time I have an x, I'm going to replace it with a 2a. So notice this is just exactly what I have right here, except every x that I have got replaced with a 2a, and then I'm going to simplify it up. So the 2 stays right here. If I square 2a, that's like 2a times 2a, which would be 4a squared. Multiply that -5 times 2a, and then I have a 1 on the outside. And all I have to change there is just multiplying that by 2. Now these are not like terms, so there's nothing I can do to combine them any further, but now I'm going to bring that -5 back in. So now if I multiply everything that I see here by a -5, that'll be my final answer. So multiply this by -5, and I get -40a squared. Multiply this by -5, and I have plus 50a, and then multiply this by -5. So that would be your answer for something like number 9. Okay, we've got number 10. Number 10, we have a picture. I'm just going to do a quick sketch of it. Picture looks something like this. Okay. So first thing that we are doing is describing the end behavior. So the end behavior basically walks you through what these 2 arrows are doing. So start with this arrow on the end here. So what we do is we say the function goes down. That's what that statement means. That means the function goes down. And then we say as we move to the left. That's what that means. So this statement right here means the function goes down. Those values are just getting smaller and smaller and smaller. That's what that arrow means. And then as x goes to -infinity, remember x moves left and right. So as x keeps going off to the left, that would be -infinity. And on the other end, this arrow up here, we say that the function goes up as our x values move to the right. Okay, so you're always going to have one of each of these. You'll always have the left and you'll always have the right. These might be one of each, like mine are here. They might both be going down, they might both be going up, or they might be swapped like that. But you will always have one of each of these because you'll always have an arrow on the left and you'll always have an arrow on the right. So that's the end behavior. Next part, determine whether it represents an odd or an even degree function. If you know the trick, this question is pretty easy to answer. This one, see how my arrows go in opposite directions? One goes down, one goes up. That means it is an odd function. If they were either both going up or both going down, then that would be even. So odd means the arrows go in opposite directions. Even means the arrows go in the same direction. And then the last part, state the number of real zeros. That's literally the number of x-intercepts that you see. So we see 1, 2, 3, 4, 5. Okay, so there are 5 real zeros. Okay, so you will absolutely have a question like that, and you'll have to answer all those same pieces. Okay, number 11, you're going to graph by making a table of values. Okay, so our function is this. Okay, so this is graph that by making a table of values. So your standard that you're going to go for is from -3 up to +3. So I, of course, don't have a calculator on me, but there are many different ways you could do this. You could literally kind of do it in your head if you wanted to. So it'll go like this. So we'll have negative, and then when I cube -3, I get -27. And then plus, when I square -3, I get 9 times 3 would be 27, and then -3. So 27 plus 27 is 54, minus 3 is 51. Plug in the -2. I start with the negative that was already there. When I cube -2, I get -8, plus 3 times 4, should be 12, and then -3. So this would be 20, minus 3 would be 17. Plug in the -1. Again, this starts as a negative, and then when I cube -1, I get -1, plus 3 times -1 squared, so that's 3 times 1, which would be 3, and then -3. So this comes out to be 1. Next, when I plug in 0, I know it's always just going to be this value on the end, because this would be 0 and this would be 0. So I get -3. That's always an easy one. 1, okay, so again, I start with a negative. When I cube 1, I get 1, plus 3 times 1 squared, which would be 3 times 1, and then -3, so this would be -1. Next one, I can plug in the 2. Starts with a negative. 2 cubed would be 8, plus 3 times 2 squared would be 3 times 4, which is 12, and then -3, so this comes out to be 1, and then I can plug in the 3. So again, start with the negative. 3 cubed is 27, plus 3 times 3 squared is 3 times 9, so that's 27, and this equals -3. Okay, so if we plot this, let's see what we get. So I told you guys, if you go up to like 30, 40, 50, somewhere in there, that'll be a good enough picture. So I'm not going to plot this one, but just make sure you have the arrow showing that it would keep going to higher and higher values. So these are my x values. And then let's say we scale by, 3, 6, 9, 12, 15, 18. Okay, so at -2, I'm up here at 17, so just shy of the 18. At -1, we're right at 1, so it'll be right around there. 0 is at -3. 1 is at -1. 2 is right here at 1. And then 3 is back down at -3. Okay, so pay attention to this leading term right there. It has an odd degree, which means one end should be going up and one end should be going down. And then it has a negative leading coefficient, which means it's kind of flipped from the original. So the shape that it should take on is kind of something like that. Left end goes up, right end goes down. So as you can see, it's going like all the way up to where the 51 would be. Kind of goes around here, and then it should be just going down from that point, according to what my degree and my leading coefficient tell me. So that's what the graph looks like. Next, I'm supposed to be answering the consecutive values of x between which each real zero is located. So my real zeros, I'm going to identify where those fall. So remember, those are x-intercepts. So I have one right here. So that one is just past -1. So it is somewhere between -1 and 0. And then I have another one right here that is right in between x equals 1 and x equals 2. And then I have a third one right here, and that is in between 2 and 3. Okay, so I have 3 real zeros. Remember, zeros, when you see that, that is just the same as x-intercepts. Those are synonymous. And the third part you had to answer with number 11 was estimate the x coordinates. That's super important. Make sure you're actually answering x coordinates at which the relative maxima and relative minima occur. So relative maxes and mins are kind of these turning points. So here, the graph is going down, and right here it turns around and starts going up. So this point down here, we call that a relative minima. It's a turning point. So we have a minimum, and then we say near x equals, this x coordinate is 0. You can just trace it back to the x-axis. So there's a minimum near x equals 0. So again, we're going down. Here's a turning point because it turns around and starts going up. And then this is also a turning point because it turns around and starts going down. So we consider that to be a max. It's kind of a little peak in the graph. And that x value would be 2 because here's 0 and 1 and 2. So there is a max near x equals 2. Okay, so that is your 5-4 stuff, and then the next several ones are from 5-5. These are just some different factoring methods. So from number 12, you've got A, B, and C. You're supposed to be factoring these completely. So this one, you have this little table, and it kind of walked you through a bunch of different methods that you could use. So the first thing you're supposed to be doing is looking for a GCF. Is there a GCF? If there is, factor it out. So here, this has 3 copies of x, this has an 8, and then 3 copies of y, so there's no GCF. Okay, so then you move into the next thing, and the next thing is by how many terms you have, and this has 2 terms, so since it has 2 terms, it's one of 3 things. It's either the difference of squares, or it's the sum or difference of cubes. Okay, so this obviously is not a difference, so it can't be the difference of squares, it can't be the difference of cubes, so we're hoping it's the sum of cubes. So this is a perfect cube, and this is a perfect cube, and this is a sum. So it is the sum of cubes. So I'm just going to write down that formula just so we have it right in front of us. And this is something that should be memorized. You just need to know how to plug in all the pieces. Okay, so that is your sum of cubes formula. So we just need to figure out what's A and what's B. So for x cubed, we know that x cubed is equal to the A cubed. So that means that A would be just x. Like if I cube x, I get x cubed. So that's what we're starting with. And then 8y cubed is the b cubed. So if we're trying to figure out what b is, remember that means like what did I cube? What did I multiply by itself 3 times in order to get this? And to cube 8, I start with 2. And to get y cubed, I start with y. So if you can figure out what A is and what B is, then the hard part's over and you just plug it into the formula. So that would go into this formula, you know, like every time you see an A and a B, you're going to replace it with those. So let's take this and we factor it down. So A plus B becomes x plus 2y. A squared, so if I square this first term right here, that's just an x squared, minus multiply A times B. So, sorry, x times 2y would be 2 times x times y, and then square the b. So if I square this, don't forget that also means squaring the 2 and squaring the y. So that would be how you factor it down according to that pattern. So again, if you just have that pattern memorized, it should be pretty easy to just plug things in. Next, you have x to the 6th, and then plus x cubed, y cubed. So remember, run through your little checklist for factoring. First thing is that you're looking for a GCF. Do you have a GCF, anything that's common between these 2 terms? And here you do. This is 6 copies of x, and this is 3 copies of x and 3 copies of y. So we have 3 copies of x in common. So we start with that, and then you just write the leftovers like this. And this actually fits flawlessly with this. That just means x is A and y is B. And so we can just plug right into the formula. Don't forget, when you do have a GCF, it just kind of stays out front. It doesn't disappear. It just stays there. So now I start with this first part. A plus B would just be x plus y. A squared would be x squared minus A times sorry, that cut me off, and I was still talking and still writing. So here's where this left off. So we had minus, and then since x is just a and y is just b, this just gets plugged in right here, and then the b squared would just be y squared. All right, and then the last one for number 12, we have this setup right here, which is totally different than part A and part B. We've got 4 terms, which if you know that little column on your chart in 5-5, 4 terms automatically means that you factor by grouping. So that's how this works. You group up 2 terms at a time. And then what I mean by factoring by grouping is you're going to look at each of those 2 groups that we just made, and you're going to take out a GCF from each one of those groups. So this first little bracket that I have, start with the numbers. So 4 and 2 are both divisible by 2. And then this one has an A and a B, and this one has an A. So they both have an A in common. And then what you do is after you take out that GCF, you write off the leftovers in parentheses. So when you factor a 2A from this term right here, 4 divided by 2 leaves you with 2. The A is divided out completely, and then there's a B left over. Plus, and then when you divide 2A out of 2A, don't forget that there is a 1 left behind. A lot of people just kind of delete it completely and don't remember the 1. And then plus this next group right here, the numbers 6 and 3 are both divisible by 3. This one has a B, this one doesn't have any variables. So it's just the B, just the 3 that we can take in common. And then we want our leftovers. So when you divide this by 3, 6 divided by 3 is 2, and then there's still a B left behind. And when I divide 3 by 3, don't forget I am left with 1. So here's how this final answer works. You take the common term, so like if you're factoring by grouping correctly, there should be a common term there. So you're going to take this 2b plus 1 as, like I said, your common term, and then once that's gone, then your second term would be the leftovers, so the 2a plus 3. And then that would be how you factor by grouping. Okay, so 13 is also from section 5. So we had a couple this time where we're solving by factoring. So this first one, part A, you've got y to the 4th minus 7y cubed, and then minus 18y squared is equal to 0. So even though this one you're solving, you still factor the left-hand side the same way that we did with all the numbers for number 12. So this one, remember, first of all, you're always looking for a GCF, whether you have 2 terms, 3 terms, whatever. So here there's no numbers that they all have in common, but this one has 4 copies of y, this one has 3, and this one has 2. So the GCF that we can factor out is a y squared. So we factor that out, take out 2 copies of y from each one of these terms, and then what I'm doing right now is just writing the leftovers. And then you still have equals 0. So don't forget, when you take out a GCF, it's still out front. It kind of makes like its own little term there. So the y squared is still out front. And then this is 3 terms. I already took out a GCF. 3 terms is just kind of your classic factoring, like probably what you think of when you think of factoring. And that's just your 2 sets of parentheses. Same factoring that we did in chapter 4, really. So the y squared would be this term times this term. So that would be y times y would give you your y squared. And then my empty spots right here, they're supposed to multiply to negative 18, and they're also supposed to add to negative 7. So that would be a negative 9 and a positive 2. So now I have these 3 different factors, and the way that I solve this is by taking each of these 3 factors and setting them equal to 0. And then I'll get every possible answer for y. So here, when I have a square, I square root. So I have y equals, and normally I do plus or minus, but the square root of 0 is just 0, and there's no positive 0 versus negative 0, it's just 0. Here you would add 9 to both sides, so I end up with y equals 9 as the second answer. And then here I would subtract 2 from both sides, so I end up with negative 2 as my third answer. So I have 3 possible answers for part A. For part B, I have a similar looking function, but it's factored in a totally different way. So this one, any number of terms, I'm always looking for a GCF, but there's actually nothing that all 3 of these terms have in common. So since it's got 3 terms, I'm just going to factor it like a classic trinomial here. So this one's different because this is an x to the 4th. Normally, we're used to just like a squared term that we factor down here. So x to the 4th, we're trying to figure out what would go right here, and that would be an x squared. X squared times x squared would give me x to the 4th. Okay, and then for my empty spots right here, I'm trying to multiply to positive 49 and then add up to negative 50. Okay, so that would be a negative 49 and a negative 1. If I multiply those numbers together, I get positive 49. If I add those numbers together, I get negative 50. Okay, so just like up above, I'm going to take each one of these terms and set them equal to 0 because this one actually did say to solve, not just factor. So here I'm going to start by adding the 49 to both sides. And then here I can also add the 1 to both sides. And this one I have an additional step because I have to take the square root of both sides. So just like I mentioned up above with the plus or minus, you should always be starting with a plus or minus when you take the square root. It's just that the 0, there was no plus or minus. There's only 1 0. So here is square root of 49. It could be positive 7 or negative 7. So that's technically two different answers there. Here we do the same thing. Take the square root. I get x equals still plus or minus. Anything but 0, you always do a plus or minus, and the square root of 1 is just 1. So if I plugged in 7, negative 7, 1, negative 1 into this equation up here, any of those answers would make it true. Okay, so that was your 5-5 stuff. Number 14 and 15 are both 5-6 stuff. So number 14, it says use synthetic substitution to find f of negative 3 and f of 4. Okay, so you want to find both of those. And here is your polynomial. Okay, so the way the synthetic substitution works is you do synthetic division the same way we did like earlier in the practice test. I believe it was number 6 earlier in the practice test. The only trick is you take exactly what you see here and you put that in a little box and you still line up all of these coefficients right here. So the coefficient in front of x cubed is a 1. In front of x squared is a negative 1, in front of x is a negative 2, and then the constant is a positive 3. Don't forget, I mentioned this when we were talking about number 6 as well, if you're missing anything, like say we jumped right from the x cubed to the x, you'd have to put a 0 in there as a placeholder. Don't forget to do that. Okay, so synthetic substitution works the same way synthetic division does, it's just that your answer is different. So the 1 moves right down, and then we start the multiplication, so 1 times negative 3 would be negative 3, and then add this column together, we get negative 4. Negative 4 times negative 3 would be positive 12. Then add this column together, we get 10. 10 times negative 3 would be negative 30. And then add this column together, and we get negative 27. So synthetic substitution, like I said, the process is the same, but your answer is different. All you want for your answer is just the remainder. So this would be your answer for negative 3. And that just means if I were to plug negative 3 into this equation right here, I would get negative 27. This is just kind of a pattern that people notice that when you did synthetic substitution, the remainder ends up being the same thing you would get if you just plug that value in. Okay, so next one, f of 4. Again, we just put 4 in the little box. Everything else is set up exactly the same. And what we would get if we plugged in 4 is the number that we're going to end up with right here. So 1 times 4 is 4. Add this column, I get 3. 3 times 4 is 12. Add this column, I get 10. And 10 times 4 is 40. Add this column, I get 43. So that means if I were to plug 4 into my equation, I get 43. So you see it's actually, depending on how many values you need, it could be kind of a shortcut. All right, so that was 14. 15, we have one of our one of our factors, and then we want to divide it out to see what's left. So given a polynomial is 3x to the third, so 3x to the third, minus 4x squared, minus 17x, and then plus 6. And we know that x plus 2 is one of the factors. So if x plus 2 is one of the factors, we put a little negative 2 in the box. Okay, so notice, huge difference. If you're doing synthetic substitution, you keep the number the same. If you're doing synthetic division and I have an x plus 2, I put a negative 2 in the little box here. Okay, so run this through again. Multiply these two numbers, I get negative 6. Add the column to get negative 10. Multiply these two, I get 20. Add the column to get 3. Multiply these two, I get negative 6. So my remainder is 0, which is exactly what should be happening, because what I'm trying to figure out here is what this leftover polynomial is. So remember, I started with an x cubed, which means this starts as an x squared. So I have 3x squared minus 10x, and then plus 3. No remainder. So the directions were to find the remaining factors, which basically means once I end up with this, I just want to factor it down. So I start with 3x times x to give me my 3x squared. And then I know that these two numbers are supposed to multiply to a negative 3. I'm sorry, multiply to a positive 3, and they're supposed to add to a negative 10. So that would mean that both terms right here are going to be negative. That's the only way to multiply to a positive and add to a negative. So to get the negative 10 in the middle, my only options are 1 and 3 or 3 and 1. I'm going to put the 1 right here and the 3 right here, and I'll show you that it works because my outside term would be 3x times negative 3, which would be negative 9x, and my inside term would be negative 1x, and that combines to the middle term I'm supposed to have. So those are the remaining factors that they're looking for in number 15. Down to 2 more problems. All right, so we got number 16 and 17, which are both from 5-7. Okay, so number 16, we are solving this equation right here, which is actually really, really similar to what you're doing in 13b. You've got this x to the 4th, so we're solving by factoring. So we have 2 different sets of parentheses. To multiply to x to the 4th, you would have x squared here and x squared here. And then you're supposed to be multiplying to 4 and adding to negative 5. Okay, so multiplying to 4, it would be 2 negatives. To multiply to 4, it would be 4 and 1. Okay, so then you solve by setting each term equal to 0. So x squared minus 4, set that equal to 0. X squared minus 1, set that equal to 0. So this one, I add 4 to the other side of the equation. Then I take the square root of both sides. So I end up with x equals plus or minus. Don't ever forget your plus or minus. And the square root of 4 is 2. Here I have the same steps. Start by adding 1 to the other side, and then solve by taking a square root. So I end up with x equals plus or minus again, and the square root of 1 is 1. So first we were looking for the solutions, which are these 2 values right here. And then it says state the number and type of roots. So I have 4 roots, and they are all real numbers. I don't have any imaginary numbers here. So I have 4 real roots, and if we wanted to be even more specific, 2 of them are negative and 2 of them are positive. All right, moving on to the last one. Speaking of categorizing things into real and positive and negative and imaginary roots, we have this function right here. Okay, so we start with that function. First, we want to figure out how many positive roots there could be. So what I do is I take the function just the way it is, and I check for the number of sign changes. So this is positive to positive, not changing. This is positive to negative, so that's our first sign change. Negative to negative, and then negative to positives. There are 2 sign changes. So that means I could have 2, and then remember from the 2, you drop back by even numbers. So you could have 2 or drop back 2 to 0. So we could have 2 or 0 positive roots. That's how you check the positive, is just by looking at the sign changes of the original function. And then to check negative, we pretend as if we're plugging a negative number in. So pay attention to the roots. Pay attention to the degrees. So this one is an x to the 4th. If I plug a negative number in there, it's not going to come out any different because my degree was already even. Here, if I plug in a negative number, it is going to come back negative. So this will change sign to a negative 3x cubed. This one, since it's squared, it's not going to come back any different. So that's still negative 2x squared. And this one, it's an odd one, so if I do plug it in, it will come back opposite, and the plus 1 is just a 1. So check our sign changes here. Positive to negative, negative, negative. And this one's negative to positive, and positive to positive. So there are 2 sign changes there. Or you could drop back by an even to 0. So those are the negative roots. So finally, I set up my little chart with positives, negatives, or imaginaries. So if I have 2 positives and 2 negatives, that leaves no room for imaginaries because my degree is 4, so I have to have 4 roots. If I have 2 positives and no negatives, that leaves room for 2 imaginaries. If I have 0 positives and 2 negatives, that leaves 2 imaginaries. Or last, 0 positives, 0 negatives, that leaves 4 imaginaries. So those are all my options. Remember, these all have to add up to 4. All right, that's our last one.